Hey everyone, welcome to This Explainer. I am so thrilled to have you here today. If you're working with or even just planning to work with fiber optic networks, you already know the deal. This technology, it's basically magic. We're talking about transmitting massive amounts of data literally at the speed of light. But here's the catch. That magic requires absolute precision. And even more importantly, it requires protection. So today, we're demystifying the whole process. We're getting into the physical safety and the rigorous testing protocols of fiber installations. We've pulled some amazing insights directly from the comprehensive guides by True Cable and Corning to build you a definitive playbook. Let's get into it. Here's our playbook for today. First, the hidden dangers of fiber. 2, essential fiber safety gear. 3, why we actually test these networks. 4, Tier 1 versus Tier 2 testing. 5, calculating the link loss budget. And finally, 6, documenting your success. All right, Section 1, the hidden dangers of fiber, protecting the human. So let me ask you something directly. Would you ever just stare right into a live laser? Probably not, right? But what if you couldn't even see it? That's the thing. The stealthy, completely invisible nature of the hazards in fiber optics is exactly what makes them so incredibly dangerous. We aren't dealing with massive, noisy, heavy machinery here. We're dealing with threats that fly totally under the radar. Let's break down the 3 core hazard categories. First up, physical threats. Fiber optic cables are, at their core, made of glass. When you cut or strip them, you create these micro-scale, virtually invisible glass shards. If those go airborne, yikes. You can inhale them, ingest them, or they can just embed right into your skin without you even noticing. Second, chemical risks. You're constantly using isopropyl alcohol for cleaning or heavy-duty epoxies for termination. Prolonged exposure, especially without good ventilation, can cause chemical burns, respiratory issues, the whole shebang. And finally, the optical hazard. Like we just talked about, these systems use lasers to transmit data. They're highly focused and often use invisible infrared light. If you look into a live fiber, it doesn't even trigger your natural blink reflex. It just silently and rapidly heats up your retina, which can cause permanent blind spots. No way we want that. Moving right along to Section 2, essential fiber safety gear. Suiting up. Because of those hidden dangers, you absolutely cannot treat fiber shards like ordinary trash. You need a meticulously clean workspace so you never lose track of fragments. And here's a pro tip. Collect those fragments using adhesive tape. It perfectly grabs those invisible shards right up off your surface. Then, place the tape directly into specialized waste containers and immediately label them as fiber waste. You have to let everyone else in the area know exactly what's in there. Now, a clean workspace is great. But strapping on the right gear, that is your true first line of defense. Think of it like armoring up. You need safety glasses specifically rated to shield against laser wavelengths. You need nitrile or latex gloves to keep those glass shards out of your skin and the chemicals off your hands. And, hey, if you're stuck working in a poorly ventilated closet with epoxy fumes, you need a proper mask. It really is that simple. Okay, Section 3, why we test networks. Testing the hardware. So why go through all the trouble? The crucial point here is that proper testing creates a roadmap. Imagine this. Your client calls you in a total panic because their brand new, super expensive network is down. If you didn't test properly, you are completely flying blind. But because you followed protocol, you created a performance baseline. You have the original as-built records. Now, you can just plug your tester in, compare the current readings to your original documentation, find the exact fault, and fix it fast. Testing isn't just checking a box for the client, it's literally your own insurance policy. Let's dig into the details in Section 4, Tier 1 versus Tier 2, executing the tests. For Tier 1, which, by the way, is the mandatory minimum level of testing required, you're going to use an optical loss test set, or a light source and power meter. You're essentially testing 3 vital things: attenuation, which is your signal loss, the length of the link, and the polarity. It is, hands down, the most accurate characterization of your network's raw capability. Now immediately compare that baseline to a Tier 2 setup. Here, we're using launch cables and an optical time domain reflectometer, commonly known as an OTDR. What the OTDR does is give you a literal visual trace. It's like a picture of the entire fiber link. It shows you exactly where your splices are, where your connectors are, and precisely where a cable might be broken. But I want to make a really clear distinction here. Tier 2 is incredibly powerful for fault location, yes, but it absolutely does not replace Tier 1. Why? Because OTDR results can actually vary based on how the user sets it up. To get true measurements with an OTDR, you have to shoot a trace from both directions, which we call bidirectional testing, and then calculate the average loss. so Tier 1 remains your undisputed gold standard for absolute attenuation accuracy. All right, let's quickly clarify some technical jargon you will definitely bump into if you're working with multimode fiber at gigabit speeds, encircled flux, or EF. Now, back in the day, technicians used a method called mandrel wrapping to condition the light launch for testing. But as data rates pushed to 1 gigabit per second and way beyond, we needed a lot more consistency. Encircled flux replaces that old mandrel method, ensuring that the light being launched into the fiber for testing is tightly controlled and standardized. And this single metric proves exactly why encircled flux matters so much. Before EF, variability between different test sources could swing wildly. Sometimes plus 20 or minus 40%. By moving to an EF condition launch, it shrinks that crazy testing variability down to a highly predictable 10% margin of error. It gives you the total confidence that your test results are real, they're repeatable, and they're accurate. Next up, Section 5, the link lost budget, proving the math. Let's see how this all builds a complete picture. Before you even turn on your tester, you have to know what a passing grade actually is. You figure this out by calculating a link loss budget. Think of it just like a financial budget. It's a simple 4-step math problem. First, you calculate the natural loss of the fiber cable itself over its distance. Then, you calculate the loss of every connector pair. Then, the loss of every splice. Add them all up and boom, you get your total link loss budget. You are literally summing up the exact tax that every single component takes on your signal. If your actual test results come back higher than this budget, well, something is wrong. Now, you might be wondering, okay, where do I actually get the numbers to do that math? Ideally, you get them straight from the manufacturer's spec sheet for your specific cable. But if you don't have that handy, this TIA standards table is your absolute best friend. It serves as the ultimate rulebook for maximum allowable fiber loss based on the fiber type and the exact wavelength you're operating at. It gives you the baseline attenuation per kilometer so you can always build a reliable budget. And finally, Section 6, documenting your success, the final reward. Listen, a network isn't truly complete until every piece of optical and non-optical data is meticulously recorded and handed over to the client. First, you need to provide optical documentation. That includes the hard data from your Tier 1 and Tier 2 tests, the attenuation, the loss, the dates, and even the equipment calibration records. And equally important is the non-optical documentation, the physical routing diagrams, connector labeling schemes, and the bill of materials. Taking the time to do this is exactly what turns a good installation into a professional legacy-grade network. There's a quote from True Cable that perfectly encapsulates the core ethos of this entire explainer. Navigating the world of fiber optics demands more than technical prowess. It's a responsibility. Technical skill is absolutely meaningless without safety and structure. If you can splice a cable perfectly, but you leave dangerous glass shards all over the floor, or you fail to document the loss budget, you just haven't done your job. It really is a profound responsibility. So, I want to leave you with this final thought. You now know the invisible dangers. You know exactly what gear you need to wear. You understand the vital difference between Tier 1 and Tier 2 testing, and you know how to build a budget. The knowledge was laid out for you, and now it's in your head. So my challenge to you is this. Are you ready to step out there, suit up safely, and mathematically certify your very first link loss budget? Take this playbook, apply it in the real world, and do it right. Thanks for joining me on this explainer, and stay safe out there.